So I'd like to introduce a senior and premier graduate student from Kevin and my labs, Winchell Chen, who's a master of many things. And today he's going to be sharing with us a tool that we found very instrumental in helping to explore interactively and visualize data from the IFE system. And he is, through the dint of extraordinary work and persistence and insight, he's been able to adapt it to Ethica Health data formats and so on. Yeah. So he'll be speaking with us about this and giving us a bit of a glimpse about how we can use powerful tools like Tableau with the Ethica Health data for custom visualizations that don't happen to be supported yet by the Ethica Health website. Winchell.
Yeah, thanks, Nate. So I'm going to talking about how to using Tableau, or how Tableau would be helpful for analyzing the Ethica produced data. Before I start to talk about Tableau, I would like to give a short introduction of the background of the data set that has been shown here or has been analyzed here. This data set was collected in a similar boot camp that is holding in Alberta. And it's a similar scenario that we have the boot camp going on for 3 or 4 days. And at the first day, we distributing the phones that is already running Ethica for each participant. And then during the boot camp, our participants consistently receive surveys and have their data recorded. So the participant was a group of people that are interested in using Ethica to create some studies. So they were both study designers, and they are also as study participants during the boot camp. During that boot camp, the participants are designed to receiving surveys every couple of regularly, and the survey including different questions which require the participants to either type in yes or no or give their comments. In that study, the GPS data, Wi-Fi data, Bluetooth data, and survey data, and all the other data that had been introduced by Nate was collected. So this is a sample of the Ethica study. So first we will look at the Tableau would be able to generating some general statistics or we call the summaries of the Ethica study, such as the compliance, as I showed here. So you can see each of the stack represents a participant. So on the x-axis are classified by the participant's ID, and y-axis represents the number of records they generated. And this is working on the battery table. If you recall, the battery data is collected regularly, and thus this can be used as a measurement of what is the compliance condition of those participants. So we see that this is a survey compliance, which indicating the survey number 170 has been finished most by these participants, while the other surveys are not so widely responded. So we further zoom into the survey 170. This time, the x-axis is the axis representing each participant by their participant's ID. And we can see different responses from different participants. And the y-axis is showing how much response they gave. This is another summary level visual.
The previous one, when you say like the different colors on the y-axis, to what does a given color represent?
The color represents a user.
Okay.
Yeah.
Okay. That's the number of the height of that particular color is proportional to the number of times that user has filled out that particular survey question.
Right.
Okay.
And because within that survey they have also sub questions. Okay. So this is a view of how the sub questions was being responded. Okay. And this is the survey's response time. This is basically dividing the response time as the hour of day. So 0 represents midnight and 12 represents afternoon. So we observe that from the collected data there's interesting patterns. Because we're having a heavy boot camp during the daytime, and so basically, and we find few responses during the lunchtime, while some other excited participants still cannot sleep during the night and just trying to fill in the surveys.
So sorry, hour of day is there on the x-axis.
Right.
You're inferring
so
the fact that some people.
Yeah. Especially the gentleman represented in the blue color.
I think I should actually mention here that is this local submitted data, completed surveys, or
this is the completed surveys. I already filtered those empty responses. Yeah.
So yeah, I don't know why it's completed surveys.
But lucky, like there's only 3 persons that are working very late. Like if you look at probably 3 extraordinary excited people. And it's very logical if you look at their patterns. Like the blue guy does not reply to any survey after 4 p.m. until midnight. So that's probably his sleeping time. And then we can plot the data over the map. So that will give you a sense of where the data was, where the survey was answered, and how that looks like. So above, in the subplot above is the GPS, like the geolocation plot of each replied survey, and on the subplot below is the time that survey has been replied. So each row represents a participant, and the x-axis represents the time.
The time that
the time of
filling out one question on the survey?
Right. Every time that one record or one answer of the survey has been returned by the participants. So, and Tableau provides the ability for you to do dynamic, to give you interactions of the data. So if you select a subpart of the time, then you'll notice that the data above, which is showing where the survey has been answered, also get filtered. So here we only see these blue people. It's probably the same person. Yeah, that's the 370, which is the person, that person, and it's probably interesting to look at that person's location. Well, he is really most of the time he is answering at midnight. It's yeah, in different places. Although he have 2 different peaks though. Like if we look at here, he mostly answered the questions at 2 p.m., 3 p.m., and 4 p.m. And there the other high cluster is 0 a.m. So.
Wow, he exhibited high mobility and time entropy.
Well, if time allows, we were trying to further investigating this, trying to really separating which cluster is the midnight response and which cluster is. This is the ASH data set, which is we collected during the bootcamp.
Study guy in Alberta. Yeah. Okay. That's why most of them happen in the hotel. Yeah, happens in the hotel and on the heat pumps.
That's scary.
We need to have like Pokemon Go that's got all these warning messages that pop up now and develop the lawsuits. Adding those human answer surveys in the car. Do not trespass while answering surveys.
Narges is car driving classifier.
Grayed out, disabled.
So Winchell, yeah. Hold on. Very interesting.
And this is of course because the limitations of the GPS, like GPS doesn't give you, it's not working well indoor. So you can also use Tableaus to investigating which time we're lacking of GPS information. So this graph is showing us like when we don't have the GPS record associated with the survey. So the x-axis is the timeline, and each row represents a participant. And the yellow color represents we have the GPS data, and the blue color represents we don't have GPS data. So if I click on the time that we don't have GPS data, then we find that in most of the time that we don't have GPS data are the time around 7 p.m. Of course, we have a highly clustered time that there are no GPS data. Finally, it is also very easy to generating a movie to looking at the GPS where the location changes over time. So if we play the movie, we'll be finding that so each little dot here represents a location response that's collected by the Ethica system.
And this is with survey?
This is with surveys.
With survey.
Yeah. So
each of those represents is a geotag survey.
Right, geotag survey. And that's playing over time. So initially, we see the survey most being answered at this hotel where we hosting the event, and right. And then this is the time that this is the 3 p.m. Sorry, this is 3 p.m. and we start to see some people. This is probably the early living people. So. Let's go back to the launch time. This is 11 p.m. Probably go back a little bit. So see, at 10 p.m., all the people are still sitting in the same place. And at 11 p.m., people started to go out and eating. And 2 p.m., some people leaving, never come back. And now it's 7 a.m. People are going to the place. This time should be the local time. Yeah. Although probably it's.
Right on the phones, though. This was the EHS study. We issued phones, and that assumes that they weren't dead, and then we set the judgment.
Yeah, but I remember looking at that, and some of them were oddly set to Gulf time.
Maybe some of the people didn't have.
I think we may have corrected them. I remember going through that. I think we may have corrected for it, but
yeah, we have had that before.
Indeed,
they were destined for the Gulf region.
So we have people in different time zones join us.
This is a nice little note for those of you who haven't had the pleasure of doing this.
I had somebody that jumped 24 hours ahead time travel. Yeah. So we got a time stamp for the next day, like on the 7th, we got a time stamp for the 8th. And we're like, yeah, she either time traveled or something happened. So we had to contact her and get her to
So
change the time.
when your phone really dies, battery is drained, update itself, usually it's a compact with Wi-Fi.
If it's not, it may go back to 2000.
Well, I haven't seen that.
We saw it. Oh yeah, we dealt with a whole. That's what the problem was in New York City. Wind chill was rather familiar with that.
All the way back to 19.
So back to 99 and 2000. And wind chill had to do the sleuthing. Yeah. So wind chill, you want to show another one now? Yeah. Or is that?
I think that's about all.
Okay. So
yeah.
So wind chill, can you summarize? I know you've been exploring many options. If you envision the situation 3 months from now, connecting something like Tableau to Ethica data, what do you anticipate? If someone from here went out and they said, "I'd like to use Tableau," and we put aside the vagaries of the exact current state with versions of Cassandra and so on, what do you think the prospect would be 3 months from now? Could they directly connect from Tableau to Ethica? Is there a good prospect of being able to do that?
Yes.
And they'd basically enter a password and username.
Right.
And then they would have an interface where they could drag data items to incorporate into one of these?
Yes. So basically, as long as the backend has been properly set up, the Tableau does provide you identical interface, just like you're using other SQL databases. It's the same way, and you never notice that what underlying it is a non-SQL database actually. So,
right.
So yes, the Tableau is a good tools to have some quick or high-level analysis of the data sets that's been collected. Although for complex queries, like if we wanted to cross-join several different tables with for example, the timestamps and other conditions, Tableau might be slower, but this is the cost of the amount of data you have already collected. A good thing is that with the Spark, Hive, and Cassandra, this whole tool chain has been set up. You have the ability to optimize certain services. So, although initially it would probably be slow, but it can become faster.
Good. And what you've done is particularly cross-link here items from surveys, including the number of responses, potentially which response they gave,
right,
et cetera, with the sensor data like geotag, geolocation.
Right. Basically, I'm collecting data based on the timelines. I'm joining different tables using the timeline as the index, and that's the way to do it.
Good. Do you have anything else you want to show right now?
Nope.
Okay. Maybe I'll just make
Okay. Yeah. The raw data can. Yeah, this is pages of data, and this data is actually being partially pre-processed. Like we've already filtered some like useless data and already do a pre-joined. And if you're interested, this is how the data looks like. Like, for example, the Has GPS data and responses. Has GPS data is post-processed, and the responses is joined from the response table, and the like the table was basically, or currently the key space was actually separated according to different sensor type of measure, like mainly according to the sensor type. For example, the battery has a battery key space, and the survey has a survey key space, and also survey has even been classified into the regular surveys or ad hoc surveys, something like that. And the GPS is usually being classified into the location key space, which is not only GPS, but the current phone also provides you the ability to locating you through the Wi-Fi network or your cell tower. So all these informations are actually considered. And additionally, like for example, the latitude, longitude are also pre-processed. So also number of records.
Yeah, the data structure is like it's grouped as Winter mentioned, grouped based on sensor, but the grouping and the tables in the database that we are using called Cassandra, or generally NoSQL database, which is the terminology used for all the databases similar to Cassandra, is different than the traditional ones that's used by a lot of other systems. So the table really doesn't mean that much in Cassandra context. It's just basically a simple grouping. You can simply just dump all of the data from all sensors in one table or multiple tables. It makes no difference. The difference, what makes a difference is how you want to access it. And we have defined that accessing the data is based on user, the year or month, the year or year and month, depending on the load of the data. That the data has been uploaded, and a bunch of other fields which is different per type of data that we collect. If it's location, that bunch of data will be latitude, longitude, speed, accuracy, and so on per record that we receive. Survey is slightly different because each survey response is one record, but itself has so many other bits of information in it. You have question type for every, well, each record actually is just basically one of them. You press the submit response. That's one record of data. But that's response to multiple questions. Question, for example, if you have 50 questions, that responds to question 1, 5, 10, depending on what flow they went through. It's the question type, the location that's been answered, the time that those questions were answered. So it's again a JSON. The text that you see here is actually all JSON format text that specifies how that survey response is submitted. When you export it to CSV, it actually streams a lot of this data, as Nate mentioned. Like, for example, doesn't include the location data, doesn't include the time data. It just simply says this question, this response. But if you actually just export it through the database, you have all this other data as well.
Right.
The location that it was answered, the time that each question was answered.
Even the question itself is embedded in the JSON server.
The question content itself is embedded in the response.
It can be very valuable as metadata.
Yeah.
That's good. Okay. Anything else you want to add right now?
Nope.
Okay. So let's give Winchell a hand. I did want to just so you had a little bit of understanding of sort of of what you were seeing there in terms of graphs, how Winchell came up with them. I just wanted to note something about that software platform that he was using, and specifically, and thanks, Winchell. I wanted to orient you with respect to Tableau. Tableau is a very, very effective, powerful, and general tool for visualization of data sets and by extension, sort of exploratory data analysis with the sort of data that's provided here. It is favored for work with fairly large data sets, so there's little problem about using it with quite large data. Just so you know, the conceptual model is one that will be familiar for those from health sciences background, which is the notion of a crosstab, a contingency table. And basically, it permits ways of aggregating the data, user-specified data over dimensions according to user-specified breakdowns. And this is a process that's almost in the bones, I think, of a lot of folks from epidemiology or or similar health science background, some biostatisticians as well. And basically, it involves a set of steps. And I'll just very briefly, this is going to go on for no more than 5 minutes, walk you through them. So the first thing is you would select data to be aggregated. And this is, the types of data items that will be coming from the database. So it might be latitude, longitude associated with a particular event. It might be speed meters per second, or a number of records that have certain characteristics. So you'll be selecting some data to be aggregated over there on the left-hand side. Winchell had that up on his screen. And then you'll select dimensions by which you want to break it down. So sometimes we'll break it down by timestamp, for example. On the x-axis, that's the columns. And then on the y-axis, we'll break it down by creator ID. And you notice those graphs he had. Sometimes he had the x-axis be persons. They'll be in the columns. And the y-axis be counts, a number of values of certain sorts. These can be achieved using different variants on this. So selecting what data to show, and then what you want by which things you should break it down. And columns and rows are very common ways to break it down. And that will define sort of a space, and then you'll choose what sort of chart type you want. And Tableau supports a wide variety of chart types. You saw a number of them in Winchell's presentation, but far, far from a full sort of exploration of them. And so, you saw a number of bar charts, for example. You also saw maps that he illustrated. And beyond that, he could have shown some of the items alternatively in a pie chart, for example. You saw stacked bars. And there's a nice interface for choosing certain chart types that once you get to know it by exploring with it some, it can be very, very quick to create charts that kind of project the data down and summarize it up over different levels. And then commonly you will further select some sort of visual distinctions you'd like to bear out different sorts of data. So for example, in this plot here, which is showing time on the x-axis and showing on the y-axis particular individuals, we might further use color to distinguish points according to their plugged-in status, whether they're plugged into AC, plugged into USB, or not plugged in at all. And that can be used here to color these. Or we might set the size according to some characteristic. We might set a label for them according to another characteristic, so we can show them as being labeled. You can then further filter the data. That's using this little area up here. You can filter the data to only show certain individuals. So Winchell had highlighted a certain apparently somnambulent survey aficionado who is entering surveys whilst wandering the fair city of Calgary. And that individual could be focused on by selecting that person within a filter. And then finally, you can additionally change the data source so that you can select different sources of data to be considered. Now, the overall picture here that underlies this is one where you have to connect Tableau on the one hand to the database used by Ethica. And Winchell and Mohammed have been working together, and I would venture, based on Winchell's comments, we'll be likely to continue working together in coming days to have a smooth interface, an interface that would provide those who use Ethica recourse to Tableau in a fairly easy to hitch up way, that it could connect over there and through a sizable pipe suck down data that could then be presented in this sort of way. In order to do that safely, you want to have a pretty good sense on what you're trying to explore and the volume of data required, so you don't use a straw to try to suck over the Pacific Ocean. But Winchell and Mohammed will be working to try to make this process of connecting data visualization tool in the form of Tableau with the Ethica servers as painless as possible for those here. And there's some work that has to be done on those fronts, there's no question. But suffice it to say that what we see on the Ethica website is just a start. Often you'll want to partner with people who have a lot of experience working with large data volumes, but there are easier to use tools like Tableau, which can provide some interactive capacity to explore the sort of patterns that you might see in the data and allow you to clue in to certain types of elements that require investigation. Okay? So that's just a little bit on Tableau, and we'll be hearing more for that, I think, in coming months as a valuable tool. And the person of note in that, as in so many areas, is none other than Winchell here. Okay? So thank you very much, Winchell, for pulling that together on such quick notice. Okay. That's all for the formal presentations that we had prepared for today. As I mentioned in the opening minutes of the boot camp, my foremost priority in this boot camp is to ensure that questions are answered. So are there any questions in light of the material that we've shown? It's only been points within a very rich tapestry. Are there any questions we could answer that might shed light on aspects of particular interest to the participants? Are there any sort of areas, the lacunae in our presentations, or points of confusion that you might like to see clarified?